So now it's time to start talking about similar triangles. That's what today's video is about. I'm Mr. Boyle. Are you ready? Hi everybody, Mr. Boyle here again. So now a lot of you have been asking, how do these proportions fit into what we're talking about today? So today's going to be the first video where we actually talk about how proportions will fit into geometry class. And the main topic here today, guys, is right there, similar triangles. And that's what we're going to be talking about in this video today, along with a couple example problems that you might see, okay? Without further ado, here we go. So first, you have a picture here that might look familiar to you. We have two triangles on the board, and if I copy the one right onto the other, you will see that they are right now perfectly congruent to each other. We've been talking about that for months. But what's going to happen this time is I'm going to take this triangle here, and I am going to make it bigger. But I'm not just doing it randomly. You will notice something. You will notice the angles did not change. They stayed exactly the same, just like in the little triangle now. The sides definitely got bigger. So these triangles are definitely no longer congruent to each other, but they still look alike. So since these triangles still look alike, what we're going to say now is that these triangles are similar to each other. So at any point when I post some notes on these videos, feel free to pause, write down anything you think is important, and then click play again. What does it mean for triangles to be similar to each other? Well, for that, let me move these a little bit more out of the way. And I have some notes here for you, and they're right here. Two things to be similar. One, all corresponding angles will remain congruent. You saw that when I made the triangle bigger, it did not affect the angles. This 61-degree angle stayed 61 degrees here. 38 degrees here, 38 degrees right there. So all corresponding angles remain congruent. That's the first thing you should always look for when we start talking about how to prove if two triangles are similar. Are my angles congruent? Second thing, which is the more complicated one, and here's our big word, all your corresponding sides are going to be proportional. They are not going to be congruent. Line segment DE is definitely shorter now than line segment CB. So that's where the whole concept of proportionality is going to come into play. Let's learn a little bit more, shall we? I'm going to scroll down right now. So here is what a typical situation is going to look like. You got two triangles. You got markings all over the place. I've told you how long every single line segment is. And then here's the key. Just like when we had congruent triangles, we have what's called here a similarity statement. Okay, similarity statement, it looks just like a congruent statement, but remember the congruent symbol was the equals with the squiggly guy. Similar is just the squiggly sign. So remember that, okay? Now, once again, this statement is doing two things. One, it's telling you that the triangles are similar. And two, it's telling you which pieces match up with which pieces. So let's just take a look here. You'll notice now you got three line segments here and three over here, and now you need to match up which pair goes with which pair. It's not that hard to figure out. The smallest side here is going to pair with the smallest side here. The bigger side here is going to pair with the bigger side here, and so on. And I can make a triple proportion out of this. And you can see, I took the side from here, matched it up with the side from here. 7.5 goes with the 5, and the 9 goes with the 6. Now, how do we know that these three pairs of sides are proportional? Number of different ways. Simplest way, I think, if you have your calculator, take out your calculator and do the division. If I do 6 divided by 4, I get 1.5. 7.5 divided by 5, 1.5. 9 divided by 6, 1.5. I get 1.5 every single time. What does that mean? That means what I did before I turned this video on is I multiplied every single one of these sides by 1.5, and that's how I got these three sides here. That is what we call scale factor. So if I were to say to you, what is the scale factor from the little triangle to the big triangle, you would say 1.5. Because to get from 6 to 9, 5 to 7.5, and 4 to 6, we multiplied by 1.5 each and every time. Scale factor. That's all I want to make for this one particular video. I'm going to try to provide a link up there to get to my next video, which is going to show you how we can actually then use this concept of similarity to find missing sides. That will be in the next video that I'll be working on now. This one I definitely think is long enough. I'll see you guys on the next video. Talk to you guys later.